All right, I think we can get started. Thanks again for joining for this webinar. We are presenting this webinar well, by the end of the month, usually on Wednesday. And in today's webinar, we're going to present event-driven scaling with Azure Kubernetes Services. As you know, in the end of the presentation, if you have any questions, there is a Q&A section at the top of your screen. And if you have any question, I will read and answer the questions by the end of the presentation. If you don't know me, just to introduce myself quickly, my name is Jair Carneiro. I'm a Director of Engineering and Solution Architecture here at QAT Global. And I have a very special presentation today with a hands-on approach to show you regarding Kubernetes, when to use Kubernetes, when to choose to use Kubernetes, what are the advantages, what are the pros, the cons of using Kubernetes. But before talking about Kubernetes, I want to give a step back and I want to talk about the journey that we follow to understand when this type of infrastructure is the ideal infrastructure for our projects. So basically, let's start with the concept of the cloud apps development, okay? This continue represents the journey from the legacy systems to modern distributed cloud native applications. When I mention cloud native applications, I'm talking about the applications that are built and will be deployed directly to cloud systems. Sometimes we start with monolithics, and then we move them to the cloud. But there are so many steps here that we have to take into consideration. On the left side here, you can see that we have the existing on-premises applications, and that is usually hosted by the company. So all the services, all the security upgrades, etc. That is done by the company, and you need people to do that, right? So you're not only spending your time and money with the infrastructure management, but you also need people to make it work. So in one end, we have the monolithic approach, and usually that's how most of the projects are started today. They are tightly coupled systems that rely heavily on vertical scaling and usually manual management. And these systems often they live in these on-premise environments and they are really costly to scale. They are hard to update and they're really slow to evolve. If you have new features, if you have to scale, let's say you have new business in another country, then scaling, patching, updating, that is really slow. On the other end, we have this fully cloud native microservice based architecture with containers, which are dynamically scalable and they are observable end to end. So you need to understand where exactly you are right now. If you are starting with these existing on-premises applications, or if you are starting with containers and microservices. There are so many ways here to take into consideration. For example, if you need agility, if you need time to market, if you need to have like IT simplification of the processes using these platform as a services approach, it's much faster because you are kind of delegating another company, say Microsoft or AWS. You are relying on them to host your own infrastructure, so you don't have to worry about it. But in the other hand, there are so many other uh, concepts that I have to take into consideration. For example, engineering complexity, the cost related. So there is always a trade-off, and especially when moving to Kubernetes. And this is where Kubernetes fits in. When you have a cloud native application, microservices based architecture with containers, and you need a full infrastructure abstraction. So using Kubernetes will enable us to run distributed workloads with high resiliency, built-in auto-scaling, and the full infrastructure abstraction is ready for you. The shift along this roadmap isn't just technical, it's organizational. It requires DevOps maturity, automation pipelines, cultural mindset change, but the payoff is really huge. You have faster releases, you have lower costs per user, and system elasticity. And Kubernetes becomes a foundational building block in this cloud native maturity model approach. Moving forward here, traditionally, as I said, we scale systems vertically. That meant increasing CPU, memory, or disks on a single machine. It's simple to understand, doesn't require much architecture change, but there are some restrictions here, like hardware caps, cost spikes, no built-in fault tolerance. If your microservices or if your system fails, what happens? You need to take that into consideration. And what is the cost of having a huge application running that is facing downtimes for 1 hour? How much money are you losing with that? With horizontally scaling, we run multiple instances of the application across a cluster. And when I say cluster, I mean a physical machine, right? We can scale out based on demand, based on scale and idle usage. If you are using your infrastructure, you're paying for that. If you're not using, you are not paying for that in most of the scenarios. And Kubernetes will enable this automatically through a mechanism like HPA, horizontal pod upscaling. And you can also do a cluster outscale, meaning you can add another machine, and then you can add or remove these machines and these nodes depending on the load that you have. If you have low usage of your infrastructure, so Kubernetes will automatically adjust your infrastructure, right? These help business to reduce infrastructure costs while ensuring availability. So on one hand, you have the reduction of your infrastructure costs, but also availability. But it doesn't mean that it's always reducing your cost, because using Kubernetes will add a lot of knowledge. I mean, you need to have a lot of knowledge with Kubernetes in order to run this infrastructure. You need to have people who knows Kubernetes very well. You need people who knows, for example, Unix-like systems, and that's another cost that you need to consider. However, designing for horizontal scale demands also stateless workloads, shared storage strategies, and not to mention smart routing. So while Kubernetes makes it easier, your application also needs to be designed in a way that supports Kubernetes. So there are so many details here that you need to take into consideration. And the question may be, what problems does Kubernetes solves? Kubernetes addresses several critical challenges in modern software deployment. First and foremost, I would say container orchestration. When you are dealing with dozens or hundreds of services, managing these services, these containers manually becomes a nightmare. So Kubernetes will automate all of these. Kubernetes is going to handle where the containers are running, how many containers needs to exist, and what happens when something crashes. So when something crashes, Kubernetes will automatically provide another pod for you, and that's going to happen automatically. It also supports declarative infrastructure via YAML manifests, YAML files, so you can define your desired state and let the system enforce it, meaning that you don't have to manually go and create all your infrastructure. You just write down your infrastructure as code, you define the desired state, and then you apply that, and then Kubernetes, your infrastructure, will enforce it. That for sure improves high availability by scheduling your system, by restarting the component that sometimes may misbehave, and all of that without manual intervention. Okay. But when it comes to Kubernetes, you need to be also an expert with containers, and there is a huge difference in today's market, in today's industry, where a lot of companies are still relying on virtual machines, and some companies, they are not using containers to run their own workloads. So containers and virtual machines, they serve different purposes, but they often get compared with each other. Bottom line, a VM will emulate an entire physical machine, hardware, operating system, and all of that. And that is great to isolate, but you always have a bloated resource use. Boot times are slower. The images for that VMs, they are often gigabytes in size. And container in contracts, they share the same host operating system kernel, but also isolate the application process and all the dependencies. So my meaning is using containers, they are much lighter, so much lighter. So often they're just a few hundred megabytes, compared to a VM that can be gigabytes. And they start in seconds, not minutes. And this speed makes container ideal for microservices, event-driven workloads, CI/CD pipelines. It doesn't mean that VMs are legacy, and you don't have to use VMs, but VMs still make sense for workloads requiring strong isolation or legacy dependencies, So when deciding between them, you have to ask yourself, do I need a OS level control and isolation, or do I need a application level packaging and speed? So that's the main question. And that is going to lead you to Kubernetes, because if you are using the containers and you need to orchestrate the containers in runtime and in production, that's where Kubernetes starts to show up. For modern applications where you need agility, portability, efficiency in containers, and by extension, Kubernetes, that's the best choice. So why container? You may ask, why? Why should I use a container? The containers become the new standard for deployment in cloud native environments. They allow developers to package the application with all the dependency into one single portable unity. And if you have to, let's say, take this container from Azure and send that to Amazon Web Services, it's totally possible because you just move the container from one infrastructure to another, and then it works. And like the joke that everybody says, like it works on my machine, right? Because the runtime environment is bundled within the code. So containers simplify CI/CD pipelines. They make deployments predictable and traceable. They're also perfect for microservices architecture, where each service is isolated, independently deployable, and can scale on its own. So if you're thinking about scaling in the right way, containers are the best option. But containers they don't solve every problem. They need orchestration, storage, network abstraction, and governance. And again, this is where Kubernetes becomes crucial, because you need to handle the container lifetime, you need to enforce policies, you need to enable observability, and so many other concepts that using a VM sometimes are not required. And they run everywhere. One of the biggest advantages of containers is their universal compatibility. You can build a container once, then run it in any cloud, or even on premise. If you have your own infrastructure and you want to run the containers in your own data center, or even a developer laptop with no changes to the code or the configuration, it's exactly the same thing. Whenever you take a container and publish that container to, it works. And this opens a powerful hybrid and multi-cloud strategy. Enterprise today can avoid vendor lock-in, and that's very crucial. If you're working with Microsoft products, but you are also working with Amazon product, it really doesn't matter. If you have a container, you don't have a vendor lock-in, right? Uh, you can migrate those workloads across these providers, or just change the uh, the traffic during the peak loads that you have in your own application. Another thing that containers also improves are tests. You can run integration tests with the same container image that you push to production. So ensure that you're reducing bugs and making the availability better. Well, portability is only as good as your practice around external dependency and test them, right? And you can run that on Linux, Windows, cloud, drones, Raspberries, IoT services. It really doesn't matter. Well, as I said before, it's just a visual comparison highlights between containers versus the virtual machine. You see, the huge difference here is that when you're working with virtual machine, you have your own infrastructure here. You have to care about the operating system. You will have to install the hypervisor. Then each one of the VMs will have their own guest operation system. So if you need another application running in the same VM, you need to do everything again. You need to install the guest OS again. You need to install all the libraries. You need to install all the applications. Where when using containers, you share the same infrastructure, the same hosting operation system. Then there is a container runtime, usually Docker, that is the most famous. But you have these building blocks here that are containers that are isolated. So that's why using containers are much faster because they are so much smaller and they have images with the size of megabytes or something like that. So when you need another application, by using a container, it's so much faster than creating a new VM, creating the operating system, applying the hypervisor, installing the guest OS. You see, there are so many steps when you need to scale your applications and you're not using containers. And this is how it works. I mean, a container image, if I do comparison here, is like a blueprint for your application. It defines everything needed to run, like your code, dependency, environment configuration, runtime toolings. And these images, they are versioned, they are stored in registry, and then you pull that to Kubernetes. So the first thing you have to do, you have to create a container Docker file, an image file, and then based on that image file, that where you create a first container and then you push that to Kubernetes to take care of that container and run your application throughout the life cycle. In most of the enterprise environments, we typically enforce policies like signing images, scanning those images, and using private registry, you know? So the image here is the foundation of the infrastructure. So that is part of your code base. And let me show you quickly here what we have when we're talking about what is an image. I have here, for example, this is a Node.js application, and this Node.js application is just a HTML file, and this HTML file runs inside the server here. So it is just a script, a very simple script. And then I have this Docker file here. So this Docker file, what it's doing is it is creating server, okay, OS server here. I'm setting a work directory for my application. I'm copying the content of my application and I'm exposing this port here 3000 and then running this application inside this container here. So if I want to do that manually, what I have to do, I'm working with Docker here. So this is a Docker command that I do, Docker images. I am inside this web folder here, as you can see, web, and I have my own application here. And the first thing that I have to do, I have to build this image. So I do this command, Docker build. Just a second, let me get here. I have everything in place to be faster. Docker build, and then I give it a name. And then I'm saying that I need to create this first container here within this own folder. When I do it, what I'm doing right now is I'm copying all of this content to inside of my container here, and that becomes ready to be published to an infrastructure. When running Docker images again, I can see that it was created. And as you can see, I told you about the size, right? Of course, this is just a demo application. So you can see that the size of the application is really small. And when I want to do scaling, I need to take that into consideration because I'm creating new containers here that are only 127 megabytes. That's the length of the container. So that's why Kubernetes and managing these containers are so fast, because instead of creating all the environment again, all the infrastructure again, all the VM, all the setup of the VM, I only go there and say, hey, give me another container and give me another container. And that can be 1, 2, 5, 10,000 containers running at the same time, right? Let me run that locally because I want to show you that the same container that I have running on my machine will work later in Azure Kubernetes Services the same way. So in order to run it, I just do a Docker run. And this is the port that I specified. And this is the image name, right? So what's happening here is that I'm running this container here on my machine. If I run this command docker ps, this is going to show me that I just started my container, my application 11 seconds ago, and that's running on this port. So locally, if I get back here and do a localhost, so this is my application running locally. The next step here, I need to push this container to a Kubernetes infrastructure where Kubernetes is going to take this container and it's going to run that multiple times, right? So this is just running locally. Same thing I do is if I want to stop this container, I just do a Docker stop and I provide the container ID. So I stop running this container locally. And right now, this is the fun part of the presentation. I want to show you um, the underlying complexity that we have with Docker. Okay, so working with Docker is no joke. Okay, this is the control plane for your container, and a Kubernetes cluster includes a master node. That's one machine, which is going to handle all the orchestration of your containers. Like here in my example, I'm just running one container in my local machine. That's super easy, right? It's super easy. But what if I have 1,000 containers running, and when the users start using my application, which containers am I sending the users to, right? So with Kubernetes, I don't have to worry about it because he's going to do that automatically. So I have this master node, which handle all of these orchestration, as I told you before, like scheduling the microservices to run, the replication. If I have to do auto scaling, failover, this is what Kubernetes do. It's gonna abstract much of this complexity and handling this cluster provisioning. Um, so this is the simple architecture, not that simple, but this is a blueprint of the architecture of using Kubernetes. And I think one thing that is worth to mention are what are pods. Okay, when I talk about pods, pods are the smallest deployable units computing that you can create and manage in Kubernetes. So basically, when I publish my container, it's going to run my container here inside a container runtime. And then when I publish my image, my Docker image here, it's going to send my container right here inside this machine. You see, this is a worker node. A worker node means this is a machine in Kubernetes, okay? And then it's going to deploy my container here. And when you see pod, that means the smallest deployable unity of computing. In reality, that's a service running inside Kubernetes that is taking my container and running my container. Um, so Kubernetes has a lot of components, and when you are installing Kubernetes, if you are a Kubernetes administrator, you have to validate all of these. You have this etcd that is a key value store using for managing Kubernetes values itself. You know, the Kubernetes API server validates and configures data for the APIs objects that you are using. The kubectl in Kubernetes, when I say that it's scheduling, it's just referencing that I'm taking my container and assigning a pod to run my container inside. And the Kubernetes Controller Manager is another service that we call it daemon that embeds all of the controls shipped with the Kubernetes services. So configuring Kubernetes and managing Kubernetes is also that is really complex, especially for production environments. Okay. And then the message is while Kubernetes reduce operational overhead, it really demands knowledge of networking, security, Linux, role-based access, and many other concepts that together you make your application run and make it super scalable. Well, now let's ground with a real-world scenario. So imagine a company that sells, let's say, smart home devices, and they just featured their flagship product on a national TV show like Shark Tank. So suddenly, millions of viewers they will hear about the product for the first time, and within minutes of that, thousands of people rush to your website where you have your application running, right? They are, I don't know, reading the specs, watching demo videos, and most importantly, they are placing orders because if you have e-commerce, you have to sell something. So they will be placing orders. Without this elastic infrastructure that Kubernetes provide, the backend would crash, right? Because you are not expecting millions of users going to your website out of sudden. So the crash view server, maybe you have a fail checkout, frustrated customers because they just saw you on Shark Tank TV and now they want to buy a product, and eventually you're gonna lose revenue. Okay, so business wise, that is not acceptable, right? But with Kubernetes, that's why we use Kubernetes because this platform can scale dynamically to meet this spike. So this is the real world scenario that I have. So as an example, number one here is a website, then you're out of Sunday on Shark Tank presenting. The question that I raise is, can you handle 1,000 orders? Can you handle 100,000 orders? So that's up to Kubernetes. So in this example, all the users start placing orders here in this order microservice. Then what I'm doing, I'm sending this order to another service in Azure that will be responsible for storing those orders. Um, if you are working with a system that require, you know, high availability, etc. Usually, what we do is we take the order and we save that order. So another microservice will take that order later and then do the processing. For example, a payment microservice. Okay, so the first thing we take the order, we save that order, so we ensure we never lose it, and then another process is gonna process that and make sure that the payment was done, right? So I have a demo here that will show that. So let me just change my screen. Just a second. And let me show you the code example for that running. Um, Taylor, can you see my screen? Just confirm, please, just to make sure it's okay.
Yes.
Can see that. Okay, awesome. So first of all, to make it work, Azure, what I have is I already created a Kubernetes services in Azure. It's running, okay? I have this container registry service here. It is responsible for receiving my container and storing my container. So I already came here. There is a repositories and I already published my container here. So my container is ready here and that's just saved, okay, for now. And then I have these service bus services as well that when I take an order, um, sending all the details of my order to the service bus service, and it's just storing my orders, and that's it. Okay. Then I have Kubernetes running here, and let me show you right here. And unfortunately, with Kubernetes, there are two ways to manage Kubernetes. You can do that uh, by this black screen, typing, or in Azure, you can also go to Kubernetes services here, and you can manage everything by using the UI. For us that are technical folks, we usually do command lines approach, but if you don't have much Kubernetes skills, you can go over here, and there are a lot of resources to manage Kubernetes, to work with Kubernetes. So essentially, what I did, I created my container, and then I push my container to Kubernetes here, right? And there is an IP here, a public IP. That's the same application that was running locally. It's now running on the cloud. And essentially, when I click here on workloads, you can see that I only have, this is my application, QAT sample. I only have one machine working. I only have one pod running my container because we are not using the website right now. Nobody's using it. So it's always going to be one ready, and until I start getting more people visiting my website. And I created the sample project here that I'm simulating. This project here is creating fake orders and sending those fake orders. I'm creating 5,000 orders and sending those orders as users that were navigating throughout my website. And this other one is the payment service. So this one is sending the orders. This another one is processing those orders, right? So if I start here, you will see on the left and right side that I started creating orders and sending orders. Just a second, this is gonna work. Okay, so left side is the order creator. Okay, I'm simulating creating orders. On the right side is the microservices to process a payment. This is not gonna work into a trigger, so I'm gonna click here. I'm gonna trigger that, and boom, I will simulate that I have 5,000 users crazy about my product. You see, they're crazy, they're buying, everybody's buying, and whoa, now I don't know if my infrastructure will handle that because everybody's buying, right? So let me stop that again. Let me stop. I know everybody's excited. My product is great, but let me stop that for a second. If I do this command in Kubernetes, I will see the same thing that I saw in the UI. You see here that I still have one available. If I click refresh, I still have one server available. But you see here, just one, right? One. Takes a little while, but sure, just one. Now I have to do a strategy, and that's my Kubernetes scaling strategy. Um, I have a scaling object here, file, and I do a script here, and I'm telling Kubernetes, when I apply this script, what I'm telling Kubernetes is, hey, the minimum amount of services will be one. But then if something happened, a spike in sales happened, I want you to create the maximum replica count up to 50. So I'm essentially creating 50 containers at the same time. But that's just going to happen if I have at least 5 orders. So when my infrastructure realized that I have 5 orders at the same time, that means that everybody's crazy about my product. Everybody's going there and placing orders, right? So this is how Kubernetes will know that what is the minimum amount of replicas that he needs to run, minimum containers, okay, or websites, if I may, and what is the maximum website count that I may run at the same time. So that's the flexibility using, right? So let me apply that Um, so what I have to do, I have to apply this scaling YAML. I am connected here already to Kubernetes, so this kubectl is a command from Kubernetes to apply something. So what I'm doing, and I'm just saying, Kubernetes, please use this scaling strategy right now. So when I apply that, oops, it's not finding because it's not in the right place. Uh, this is within Kubernetes folder. Yeah, it's right here, scaling YAML. So when I do again this command, apply scaling, that's the trigger that Kubernetes needs right now to start scaling up based on the messages that I'm receiving, the orders that I'm receiving, right? So let's run again. So let's go crazy again about the orders, about my products, and let's see how these containers quantity will start increasing hopefully. Um, let's simulate that again. Let's click here to simulate that they're buying. And let's go back to Azure, visually speaking. It usually takes, oh, here, you see, you already noticed, that I have sales coming and increase the amount of containers automatically because everybody's buying my products, my server is super busy, and I don't have to worry much about it. So let me refresh again, and you see that there are 14 VMs now, 14 containers running at the same time to handle that scale. Now I have 28. And why is that? It's increasing up to 50. And it means that I'm adding more containers and more containers and more containers because I have a lot of people buying my product, placing orders, and look how beautiful it is. It's creating and creating, creating, right? Um, and then how many I have here? Let me go back again and stop. And this is the nice part of 50. You see, so I have 50 servers, 50 containers running at the same time because they noticed that a lot of orders were placed, and then Kubernetes is creating new servers, new containers, new pods, if I may, to handle that spike. And I can go to the other resource where I'm receiving the orders, and I can show you that I really had a spike in the sales because I'm sending everything here to these storage right here. You see? So I had this spike here, and then right here, I just had one container running, but out of sudden, everybody's buying. So Kubernetes is taking care of that, right? I received 543 orders. Okay, here a message because they sent in a message, but it could be orders. So that's how Kubernetes is responding to event-driven, and that's the meaning of event-driven. Something happened, right? The event happened, sales, something happened, and I need to be aware of that, and I cannot lose sales. So when that happens, the nice thing is that I can the let me show the plots again. And what is going to happen is now I'm not sending any order. I'm not placing orders, right? So what's going to happen is in I don't know minutes, Kubernetes will start to deallocate all of these services because nobody's buying again. So that's the flexibility that we have when using containers and Kubernetes. And you see here that there is a age column here, and that's when that VM was created, like this one 51 minutes ago. This was the first VM created, the first container actually. that was created. And these other ones, they were created on demand just to make sure that I not losing sales and placing orders, right? So essentially, we use YAML files. We do this strategy with files, and everything I do inside Kubernetes, I have to manually do all the strategies. Like this is a scaling strategy, right? I can change that. If I want 100 here instead of 50, I go here, change to 100, I delete this scale rule and create another, right? So essentially, it may seem easy, it may seem fast, but all the underlying infrastructure was already created and configured, etc. So this is just the scaling strategy. And there are many other scaling strategies that we may use. For example, if we have CPU spikes, if we have memory usage, anything we can track and we can scale and have metrics. If you have a metric, you can scale. Okay. Well, that was exciting for me. I hope it was exciting for you as well, you know. So just let me go back here to the slides. Um, just a second again. And let's open for questions if there are any questions. Sure again. Um, any questions? I'm open now for Q&A. No questions. Was that nice? Was that not nice? I hope so. And then if there are no questions, let me go to the end of the presentation and talk about our next webinar. So our next topic will be testing strategy using AI. That's going to happen uh, by the end of the month. But it is in September. I'm sorry, it's not August. It happens September. September. Yeah, it's going to be on a Friday, same time, pretty much. So I'm really excited, and the registration will open soon. If there are no questions, I'm stopping here, and I really appreciate your time. Thank you very much.